when that stimulation is being provided, it enters, the spinal cord through type 2 and 3 and so on, different nerve fibers, okay? And that stimulation, when you provide that stimulation, if it's done manually, people should feel the chi. So it's like a kind of feeling of heaviness, not quite pain, but they definitely should feel some sensation, right? If you put the needles in and they don't feel like anything, you probably need to stimulate that needle a little bit. How much you stimulate that needle, how long you stimulate that needle, how vigorously you stimulate that needle, that depends whether you want to do tonification or dispersion within TCM. In a more sort of modern way of doing it, you can use electric stimulation. I'm going to go into details about that, but you can essentially use different type of frequency and intensity of the electric stimulation to achieve that sort of a tonification of dispersion of the energy. So anyway, so that substance essentially, so that stimulation enters the spinal cord, right? And then on the one side, it affects the anterolateral tract, but as it does, it also goes, to activate the gate mechanism, right? So that other slide was the sort of a cross-section of the spinal cord that I was explaining to you. So you essentially get essentially release of enkephalin and the endorphins and a bit of a GABA at the substantia gelatinosa, which creates presynaptic inhibition of the T cells. But then that sort of action potential travels up the anterolateral tract towards the midbrain, towards the brain. And then it activates in a cascade sort of a structures within periaqueductal gray, within the, and so releases certain, it's like a whole transmission of sort of impulses that essentially create activation of structures within medulla oblongata, such as the raphe nucleus, that then activates descending pathways in the dorsolateral tract. Okay, so you see the arrow pointing back. And then it can create both. It can create either the reactivation on reinforcements of the gate by creating activation of substantia gelatinosa, which reinforces presynaptic inhibition of T cells, or it can create postsynaptic inhibition of T cells. So T cell can be inhibited before through gate mechanisms and reinforce gate mechanisms from the brain centers, but it also sends projection after. So after the nerves sort of leave the T cells, and it creates postsynaptic inhibition of those impulses. And then it also activates lateral reticular nucleus, and that essentially releases norepinephrine at the segmental level of the spinal cord, which again creates postsynaptic inhibition on the T cells. But that's not all. So that stuff happens while you're essentially creating that stimulation. But if you do specific modes of acupuncture stimulation, you can also activate accurate nuclei within the spinal cord, within the midbrain, within the hypothalamus. And what happens is that they release beta endorphins in the brain, and those beta endorphins activate or reinforce that sort of a second loop. The difference being is that this is not that transient, so it actually lasts a long time. So when you're looking at studies done on acupuncture done in particular way, you can actually have increase markers for RNA found in the brain over 40 hours after acupuncture stimulation is done. So as much as that gate mechanism is very short-lived. So as long as there is a stimulation, the pain is being modulated, okay? And as long as that sort of a stimulation through periaqueductal gray reinforces the gate mechanism, but it's short-lived, if you actually stimulate nuclei within the hypothalamus, then you can get much prolonged action. So you can get control of the pain lasting for days. And if you do it often enough, that can actually translate to more cumulative way of controlling the pain. Okay. But the other thing what happens is that when you activate the posterior nuclei in the hypothalamus, that also sends projection towards the pituitary gland. It's like a little gland inside your brain. And when pituitary gland is being activated, okay, it releases beta endorphins and it releases adrenocorticotropic hormone, but into the bloodstream. So that's a gland that sends stuff into the bloodstream, not to the brain. So then you have flow of those beta endorphins, throughout the body in relatively small quantities. But more importantly, it releases adrenocorticotropic hormone, which is essentially a hormonal messenger, chemical messenger that is released into the bloodstream. And when that messenger, when those molecules get to the adrenal glands, okay, you get release of cortisol, which then has anti-inflammatory actions at the distance, right?